I am back with you for the rest of page 117. This will be problems 14 and 15. And I have brought these over to my notebook to work them. So let's take a look at this story. Tessa and Corinne are trying to determine how many centimeters high each floor is in the building. Corinne drops a ball out of the window, and Tessa counts how many seconds it took the ball to hit the ground. On floor A, the ball's position from the ground is represented by the table of values below. On floor B, it took the ball 3 seconds to hit the ground. The position function for a ball dropped from a height h in centimeters with respect to time, seconds, is represented by P of t, and that is the function. And then the table is giving me the height of the ball for floor A. So let's take a look at what we are given. The first thing that I notice is right here. For floor A, the height at 6 seconds is 0 centimeters. So that means that the ball from floor A hits the ground in 6 seconds. So for floor A, we have 6 seconds, 0 centimeters. And for floor B, we have 3 seconds, 0 centimeters. And that's given to me right here. 3 seconds to reach an altitude of 0. Now, I'm going to use the position function to plug in these values. So I'm going to use this. I can't copy that. I'll have to write it. I'm sorry. Let me come down here. So we have P of t, which remember is another way of saying the height, is negative 490 t squared plus h. Okay, and we have 2 points. Remember, for floor A we have 6, 0, and floor B we have 3, 0. So let's plug those values in and see what we get. So when t is 6 seconds, let me go ahead and write it in function notation. When t time is 6 seconds, we have negative 490 times t squared plus h. And remember, P of t, or P of 6, is the height, and that's going to be 0 when you have 6 seconds in the formula. So we are about to find out the height of floor A. And I do need a calculator. There's one. Thank goodness. So this is going to be 0 equals negative 490 times 36 squared. Excuse me, no, that is squared. 6 times 6 plus height. So I have 490 negative times 36 is negative 17640 plus h equals 0. And so I'm going to bring this number over to solve this equation. And that tells me that the height of floor A, because that's the point I used, is 17,640 centimeters. And then I'm going to do that again for the other floor. So let me write my function. And this time we're going to use t of 3 seconds. So we have negative 490 times 3 squared plus h. And this is height. We want the height to be 0 when the ball hits the ground. So we have negative 490 times 9 plus h. So 490 times 9 is 4410, and that is negative. Plus h is 0. And then let's add that to both sides and cancel. So I'm left with 4410 as the height for floor B. So I'm going to go back to my story, and I think I'm going to put it right here because I'm going to need it. I'm going to sketch a building. Okay. Whoa. Don't want that building, do we? And I'm going to put the ground in. So this is the ground. This represents the x-axis. And here is the y-axis. So I'm going to erase this, but let me superimpose a coordinate plane here. So just to show you what I'm doing. So these are my y's and these are my x's. Okay. Now that that's moved out of the way, I'm going to put in 2 floors, just estimating where they're going to sit. Well, I'm trying to get it straight, so let me use the snap to. And then here's this one. Now, I know from the math that I did that floor A is much higher. Floor A is at 17,640. That's right here. So at the point that Corinne is holding the ball, 0 seconds have passed. She hasn't dropped it yet. So this point is the y-intercept for floor A. Whoa. Let's make it actually a point, and hopefully that. So 0 seconds for floor A. The ball is at 17,640. This thing is going wild on me. And then floor B, before she lets go of the ball, it is at a height of 4,410, I believe it was. Yes, centimeters. So this is floor B. And I used that position function to find the actual heights, which in this case are the y-intercepts, because that's where the ball is before it's dropped. Okay, let's look at the options for number 14 and see what we can come up with. Floor B's y-intercept is greater than floor A's y-intercept. So this is saying that 4,410 is greater than 17,640. That is a false statement. The ball was in the air 3 seconds longer for floor A than for floor B. That is true because it took the ball longer to fall from floor A than it did from floor B. And let me go ahead and draw what we're saying there. Here's an x-intercept. So at 3 seconds, ball B hits the ground. It took ball A 6 seconds to hit the ground. So this statement is a true statement. Both position functions have a maximum value. That is true. They're different values, but for A it is 17,640 and for B it is 4,410. Floor A's position function is always greater than floor B's position function. That is a true statement. At no time is B greater than A. And both position functions decrease when x is above 0. That is also true, because if the x's are in this area, the functions are falling. They're decreasing when x's are above that 0 point. Here would be 0, 0. So when x's are increasing, the functions are decreasing. So the statement that is not true is going to be A. And then what is the difference in height of floor A and floor B? Well, difference means subtraction. So I'm going to take this height and this height, and since I have them lined up, I can do it. I can't do it in my head if they're not lined up, but I like answer D for that one. So let me check these just to be sure that we're in the right. This was page 117. 14 is A and 15 is D, as in dog.